Hello everyone, welcome to the course Computer Networks. This is Parvathi, Assistant Professor, Department of CSIT, MLR Institute of Technology. In today's session, we are going to discussing about routing algorithm types and optimality principles in network layer. These two topics we are going to discussing in today's session. First, let us see the overview of today's session. Today, we are going to discussing about what is routing first of all. And next, we have to discuss about routing algorithm. What is routing algorithm? Next, we will be discussing what are the different types of routing algorithm. And next, these two types are the routing algorithm. Those are the adaptive routing algorithm and non-adaptive routing algorithm. These two types we are discussing in today's session. Next, we have to see the differences between adaptive and non-adaptive routing algorithms. And next, finally, we have to discuss optimality principle in network layer. These are all topics we have to discuss in today's session. First, let us see what is routing. Routing. It is the most important functionality in network layer. Already in previous class, we discussed what is routing, right? Routing is nothing but we have to select the best path. What is routing? Exactly, we have to select the best path among the all paths from sender to the receiver. Whenever we are transferring the data from sender to the receiver, we have to select the best path from that all paths transmitting from the source to the destination. We have to select the best path, that is the routing. To determine the route, means to determine the path taken by the packets from the source to destination, we have to use some routing algorithms. Means which path is the best path for sending the data, for sending the packets from the source to the destination. So that we are going to use some routing algorithms. So first of all, what is routing algorithm? Routing algorithm is, it is a procedure that lays down the route or path, that may be route or path, to transfer the data packets from the source to destination. Means routing algorithm gives the exact route for sending the data, means giving the best route for transferring the packets from the source to destination. They can help for the directing the internet traffic efficiently. Means which route having the traffic, which route having the no traffic, like that it is giving some directions for transferring the packets. After data packet leaves its source, means whenever the data packet is here, that is the source, it leaves its source, it can choose among many different paths. Means for sending these particular packet, it will have multiple paths for sending the data. Many different paths. To reach the destination, it will select the best path. That is the routing algorithm. This routing algorithm, it is a mathematically computes the best path. Means finally what it will give? It will give the best path. That means least cost path. Means whenever we are selecting the particular path from source to the destination, that path should be least cost. Least cost also at the same time also. At the same time, it is also providing the least cost, time. These are all the main for the providing the best path using the routing algorithms. That is about the routing algorithm. And next one is what are the different types of the routing algorithm? There are two types of routing algorithms. First one is the adaptive routing algorithm and second one is the non-adaptive routing algorithms. This adaptive routing algorithm again defined into three categories. Those are the centralized algorithm, isolated and distributed. These three comes under the adaptive routing. And coming to non-adaptive routing algorithm, here it is going to be divided into two types, that is sliding and random walks. These two comes under the non-adaptive routing algorithms. First, let us see one by one what is adaptive routing algorithm. Next, we will discuss what is non-adaptive routing algorithm. Then we will discuss what are the different types of adaptive and non-adaptive routing algorithms. First, adaptive routing algorithm. What is adaptive routing algorithm? This algorithm is also called as the dynamic routing. Dynamic routing is nothing but it can select based on the situation, it will select. That is the main thing. That is the dynamic condition. So, adaptive means mainly it is following the dynamic routing algorithm. It makes the routing decisions. Whatever route if you want to select the route, so that can be routing decisions dynamically it will select depending upon the network condition. Based on the network, which network we are using for sending the particular data. Suppose this is the destination, this is the source. So, if we want to send particular packet to this destination, first it will select, how it will select? Dynamically it will select based on the network condition. Which network is going to be good? Based on that it will select the route. It constructs the routing table. Means here some routers are there. Here these are the routers. Means it will construct the routing table depending upon the network traffic and topology. Based on the, every time it will construct one routing table. What it will contain? Based upon the what? Network traffic, means which route having the more traffic, which route having the less traffic. Based on that, at the same time, based on the topology also. Topology means how physically, topology exactly meaning what? Physical arrangement, how all devices are all arranged physically. That is nothing but topology. Based on this traffic and topology condition, we construct a routing table. That is adaptive routing algorithm. They try to, what exactly routing table will do? They try to compute the optimized route. Based on the routing table, we are selecting the optimized route depending upon the hop count. Hop count, every time we are focusing on the hop count to transmit the time and distance also. Focusing on the hop count, time and distance. Based on that, we are selecting the best path for transferring the packets from source to destination. So, routing decisions, whatever routing we are selecting, those decisions are based on the measurements or estimates of the current traffic and topology. Mainly two conditions, those are the traffic, means which route is having the less traffic. In real time also we can select this example. See, traffic means, suppose if you go from some Hyderabad to Vizag, means number of routes are available from Hyderabad to Vizag. But what we are selecting, based on the traffic, we are selecting the best route. Based on the topology also. Topology means how physically, how much it is efficient to go that particular route. Based on that, we are selecting the route. That is the routing decisions. The stability is more important goal of the routing algorithm. These all are comes under the adaptive routing algorithm. That is the dynamic routing algorithm. Based on the situation, based on the traffic, based on the topology, it will select the route at that particular time only. That is the adaptive routing algorithm. And what are the different types of the adaptive routing algorithm? Those are three types of adaptive routing algorithms. First one is the centralized algorithm, isolated algorithm and distributed algorithm. These are the three types of the adaptive routing algorithms. First, what is centralized algorithm? Centralized algorithm mainly talking about least cost path. Mainly it is talking about least cost path between source and destination. Means this is the source and destination. Whatever route we are taking, that route is having the least cost. Notes by using the global knowledge. How it is going to be exactly, it will select as a least cost based on the global knowledge that will collected from the all other nodes about that particular network. So it is called as the global routing algorithm. Mainly what it is going to be tell, least cost path it will select for sending the data between the source to the destination using the global knowledge. That is the centralized algorithm. And coming to isolated algorithm. What is isolated algorithm? This algorithm mainly talking about the, means it will also select the best path from the source to destination. The mainly it is focusing on the local information. So here also it is also least cost path it is also selecting, but it collect the local information, gathering the information from the other nodes. That is the isolated algorithm. And coming to distributed algorithm. Distributed algorithm is nothing but it is a decentralized algorithm. Mainly it is focusing also, it is also least cost path only from the source to destination, but it is in distributed manner. So here also in distributed, all the cases centralized, isolated and distributed, all are talking about least cost path only, but in distributed it is distributed manner. That is the three types of the adaptive routing algorithms. And coming to non-adaptive routing algorithm. What is non-adaptive routing algorithm? See here, non-adaptive is nothing but static. Previously adaptive is a dynamic, here it is the static routing algorithm. It constructs the static routing table. Previously we construct the dynamic routing table, here we are constructing static routing table to determine the path through the which packets are to be sent. For that we are going to construct a routing table, that is the static routing table. So this static routing table mainly it is constructed based on the routing information. Means the route is going to be fixed, that is nothing but the static. Whatever route we are selecting, means suppose if I want to go from source to destination from Hyderabad to Vizag, I fix the route. Based on that route only we have to travel. So that is the static routing. Based on the routing information, we are selecting that particular route. That is, for that we are going to construct the static routing table stored in the routers when the network is booted up. When it is going to be started, that time only we are going to select the route. So do not base their routing decisions and measurements or estimates of the current traffic and topology. Here we are not following any traffic and topology concept. Previously in dynamic, we are focusing on the traffic and topology. Based on these two conditions only, we are selecting the path from the source to destination. But in this non-adaptive, we are not focusing on the traffic and topology. So the choice of this route is computed in advance. Means whatever route we have to travel, that route we have to select before only, computed in advance. That is going to be in offline, and that can be downloaded to the routers when the network is going to be booted. When the source is going to be start to send the data from that particular place, from these different routes, first it will select the route. First it has to select the route. Based on that route only, means that is going to be selected before advance only, we are selecting the route for transferring the packets. That is the non-adaptive routing. That is nothing but is static. The route is going to be fixed before transferring the packets. And these are the types of the non-adaptive routing algorithms. Those are the two types, flooding and random walks. Flooding is nothing but flooding the data packets arrive at the router, that it sent to all outgoing links except the one it has to be arrived. Means flooding. Flooding exactly we can use that word in rainy season. Floods means it can go anywhere. See here, flooding is nothing but, so here the source and destination. Here this is the source and destination. It can be traveled through multiple routers. So here source and destination. These are all the different routers. This is the source and destination. So here my packet is there here. This is the starting. So the data packet is arrived at that particular router. This is the first router. So it is sent to all outgoing links. See, these all are the outgoing links. It will send to all outgoing links except one it has arrived. Except one it has arrived. Instead of that, excluding this, we can send all other nodes. That is the flooding. This flooding may be uncontrolled. Flooding may be uncontrolled. This can be controlled. Selective flooding. Here it is also selective flooding also happened in the flooding. So next one is the random walk. What is random walk? It is a probabilistic algorithm. Mainly it is talking about the probability. Where a data packet is sent by router. How it is going to be sent by router? To any one of its neighboring randomly. Random walk is mainly nothing but, suppose here is the sender. Here it is having the 3 routes for sending the data. But it can send randomly, it will select whichever route it will want, it can select that particular route. Randomly it will choose the route. Randomly it will select the path is nothing but the random walks. That is about the flooding and random walks in non-adaptive routing algorithms. And what are the differences between the non-adaptive and adaptive routing algorithms? See here first one, the adaptive routing algorithm mainly talking about, it is for exchanging and updating the router table, we are going to use the routers in adaptive routing. And coming to non-adaptive, it involves the network administrator. Non-adaptive. That's why we are involving network administrator. It is a static. Non-adaptive means static. Adaptive means dynamic. It is the dynamic. So here we are exchanging, for that we are going to use the routers. This algorithm creates the routing table based on the network condition it will create. Means we are focusing on the traffic and topology. That's why based on the network condition it will create the routing table. Here the algorithm creates the static table. It is a static that is going to be fixed in order to determine when the sender is present and which node. Means before going to start that particular packet only, we are creating the static table. This algorithm mainly dynamic routing. Adaptive is mainly talking about the dynamic, where it is going to be talking about the static routing in non-adaptive. So in adaptive routing algorithm, the routing decisions are made based on the network traffic and topology. Based on the traffic and topology only, we are deciding the best route in adaptive routing algorithm. And coming to here, it is not going to talking on the traffic and topology. It is not going to be there in traffic and topology in non-adaptive. And adaptive routing algorithm more used. These are the more used compared to the non-adaptive, because these are the dynamic algorithms. That's why most of the cases we are going for the adaptive routing algorithms. And whereas the non-adaptive routing algorithms less used in real time. So it is mostly used for the open, complex and network topologies. We are going open and complex topologies. We are going to use adaptive. And it is mostly used for simple routing, closed network topologies. We are going to use the non-adaptive routing algorithms. But the adaptive routing is complex and non-adaptive is simple, because the route is going to be fixed. Before sending the data, we are fixing the route for sending that particular packet. That's why here it is the simple in non-adaptive, and it is more complex. adaptive because the route is dynamic. That's why it is more complex. These are the some differences between adaptive and non-adaptive routing algorithms. And next we will see some differences between routing and flooding also. Routing is nothing but here the table is going to be required in routing. For flooding there is no routing table. It may give the shortest path. If we go for routing concept, it will give the shortest path. It always gives the shortest path. It may give the shortest path, but flooding it may give the shortest path. It is less reliable. Routing is less reliable and flooding is more reliable. Here the traffic is less. Here the traffic is high in flooding. There is no duplicate packets in routing because we are selecting the path. So here duplicate packets are present because it is flooding. Means it is going to all other nodes. That's why duplicate packets are going to be present in flooding. These are the differences between routing and flooding. So here next one is the network layer optimality principle. What is the optimality principle here? See, what is the main purpose of the routing algorithm means what? Selecting the best path. That is the routing algorithm, right? Here we are choosing the optimal path. What is the optimal path exactly here? Optimal path is nothing but it is a particular router to another, how it is going to be transferred. So how we are selecting the optimal path? It may be least cost. Mainly it is focusing on the least cost. Next one is the least distance. All are going to be least only. Least cost, least distance and least time also. Least time and least hops also. Least hops also. The combination of anything. If we combine this all, then only that can be least path. Means best path. That is the optimal path. Optimal path is nothing but the best path. How we are selecting the best path? Based on the least cost, least distance, least time and least hops also. That is the condition for selecting the best path. So it can be proved as the principle, the optimal principle can be proved in the following. See, the optimality principle, if the router J is the optimal path from J to K, then the optimal path from J to K are also falling down. See means suppose if I is there, here is K is there. I is there, K is there. From I to K, I am saying as this is the best route, best optimal path. Optimal path. This is the optimal route. Suppose in between this one more node is also there, J. Means I to J also optimal, J to K also optimal because I to K optimal I said. That's why I to J, J to K also optimal. That is the condition. The set of optimal routes from all sources that are going to be given to the destination that can be form a tree. That tree is nothing but the sync tree. Whatever available optimal routes are there, those combining all called as a sync tree. The distance metric is a number of hops. How it is going to be considered? Based on the number of hops, we are considering the distance metrics. The goal of all routing algorithms is nothing but what? Discovering the best route based on the sync trees for all routers. That is the main goal of optimality principle. So this is the network, this total network connecting to all nodes. So coming to here is the sync tree is nothing but here there is no there is no loops. The main condition is there is no loops. That is the sync tree. This is the optimality principle. See this example, we can understand better the optimality principle here. So here see this example. Here the routers are G, H, I, J, K, L, M and these are the different routers. Here are the routers. So let the optimal route is I to K. Here is the I, here is the K. These two, what we are saying, I to K is the optimal route. That is also we selected is the green path. Means whatever green line is there, this is the whatever route we selected in the green line, that is the best path we said. So the route is I to G, G to J, J to L, L to K. I to G, G to J, J to L, L to K is the best path. According to the optimality principle, the optimal path from J to K. Optimal path from J to K means what? From this example, J to L, L to K is the optimal. Within the same route only we have to select the next one, optimal path. That is the, if you want to go from J to K, which one is the best one? J to L, L to K. That is the best path. So, suppose if you find the better route from J to K, suppose if this is not the best route, this is not the best route. If you found one more route, that is nothing but J to M, M to N, N to K, this is the best route. How the next, what is the total optimal principle? total optimal path from I to K, how it is going to be happen? So I to G, G to J. From J onwards, we are selecting the another route. J is nothing but J to M, M to N, N to K. That is the route. So this is the route I to G, G to J, J to M, M to N, N to K. That going to be indicated in the orange line. This is the orange line. After changing the route, if we found one more route, then that is called as the optimal route. So suppose if you want to go from I to J, what is the best route? I to G, G to J. This is the best route for transferring the packets. This is about the optimality principle. Coming to the summary, in today's session we discussed what is routing, what are the different routing algorithms are there like adaptive routing and adaptive routing. And next we have seen the differences between the adaptive and adaptive routing, and we have seen the differences between routing and flooding also. And next we discussed what is optimality principle with example. This is about the routing algorithms and types. Thank you.